Alright, so while you are doing the warm-up problem, I will come around and I will collect the homework packet that is due today and the quiz that you should have scored for yourself. So clearly you should have a score somewhere at the top of your side of the quiz. And then if it's not a perfect score, you should probably have it justified some way, or so that I can see how you graded it, and then determine if I want to go with your score or with my score. Okay? All right. So have both of those out while you're doing this. Sometimes those directions get in the way. You weren't alone, just so you know. You're so focused in on. So I got a domain here of all real numbers, but x can't be 0. Yes? I've got a vertical asymptote then at x equals 0. Yes? I've got a horizontal asymptote. I've got a degree on the top of 1. I got a degree on the bottom of 1. So that's a y equals a over b. So that's 2 over 1. So that's y equals 2 for horizontal asymptote. I'm going to slide this down a little bit. Raise this one up a little bit. And then ungroup it right away. Nope, it didn't. Usually it pops it right back into where it should go. There we go. Yeah. And so then my y-intercept is going to be none. Because if I have a vertical asymptote at x equals 0, I can't have a y-intercept. My x-intercept, 2x minus 1 is equal to 0. 2x is equal to 1, so x is equal to 1/2. So that gives me an x-intercept of 1/2, comma 0. Okay, so put some stuff on here now. X equals 0, so that one I would definitely do the old slash mark down because it's very important. All the way down. Y equals 2. It's here. I don't have an x-intercept, or excuse me, I don't have a y-intercept, but I have an x-intercept at 1/2, comma 0. So then that leaves me with parts to choose from here. So let's go with, on the negative side, I'd go -1. So that's going to be -2 minus 1 is -3 over -1. So that's 3. Then I would go -2. So that's going to be -5 over -2. So that's going to be 2.5. And then I would go with -10. That's going to be -21 over -10, which is 2.1. Then I would go with 1. 2 minus 1 is 1, over 1 is 1. And then I would go 10. 19 over 10 is 1.9, which is right there. So that then allows us to say that my function comes in through here, makes a big turn up, comes in from here, makes a big turn out. Yes? Okay. Said we had to do behaviors on this one. Yep. Asymptotal and end behaviors. So let's do end first. As x goes to negative infinity, my function g of x approaches 2 from above. As x goes to positive infinity, g of x approaches 2 from below. Yes? Asymptotal behaviors. Some people still on their formatives are giving me weird numbers here instead of what the actual horizontal asymptote is. So this would be as x approaches 0 from the left. Oops. 0 from the left. G of x is going to positive infinity. And as x approaches 0 from the right, g of x is going to negative infinity. Questions, comments, concerns, clarifications? Yes, ma'am.
If we do f of x on the test and it's like g of x will take place after that.
How mean do you think I am?
I don't know. Just don't do it.
Just don't do it. Yeah, just be cognizant of your problem.
So just as a reminder, so the asymptotal behaviors, it's always like the number's always the vertical asymptote, and then for the end behavior, the numbers are whatever the horizontal asymptote. Right? Yeah.
Yes.
Why is it called end behavior? It's infinity.
End behavior?
Yeah.
Because that's the ends of our graph. Left and right ends of our graph.
That adds up.
Okay. So, what happens if in f of x, p of x and q of x have a common factor? What happens then? So if I had a fraction, let's say 6/8, what would you do with 6/8? Simplify it how? Top and bottom both by 2. Okay, so this is really like 2 times 3 and 2 times 4, right? And then you factor out the 2's, and so then that leaves you with, I gotta get to my color, factor out the 2's, and then that leaves you with just 3/4, right? And then you would go from there, right? Well, what if it's like what if it's like that?
All the x plus 3, those cancel out each other.
Okay.
So when she just have x minus 2 over 1.
Right? What if it's like this? Gotta think of a good one now.
Can you simplify it like this?
Now you tell me.
Yes.
So what do you get?
So then it would be 8.
8? Do we agree with 8? So why are you shaking your head like that? Seems kind of odd. Yeah. Seems kind of funky math. Yeah. Okay, let's try a different one. This one, side note. Can't be anything done to it. What if we had that? Somebody other than Sid.
You can cancel the X.
No, I can't because I couldn't cancel out the X's in the green one.
Because aren't they the same?
What? But the X's were the same in the green one, and I couldn't cancel them out because a lot of people were shaking their heads that 8 wasn't the funkiest of funkies.
You can factor it. You can factor out X plus 5 out each.
So this really is
X minus 2 and X plus 5.
and this really is
X plus 5 and X minus 5.
and then those cancel each other out, right? Okay. So what happens if we have common factors? Gotta simplify it first. Okay? So that leads us to step 0. We finally are at step 0. So this should go on your sheet. Step 0 is we need to simplify our fraction first. I'll get it. Okay? Okay. So we need to factor the top and the bottom. If the same term is in both, we cross it out and we start with a fresh, brand new function. Because we want simplified functions. So that makes it a little easier on us. That then leads us to step number 5. Step number 5 says, if something can be factored out in step 0, then that creates a whole. So if something is factored out, we set it equal to 0, and we solve that mini equation. We then plug that value back into our new function, our factored function, if you will, and we find its corresponding y value. That x and that y together are the coordinates of the whole on the graph. And you literally put a hole on your graph. You circle that point and nothing can fill that hole. So you're going to have to pick up your pencil when you get to a hole. Okay? Ellie, going back to your, would I take off for f of x and g of x and stuff like that? No, I wouldn't. But if you draw right through your hole, yes, I will. Okay? All right? Okay. So it's a two-step kind of a deal. Now, the downfall with creating simplified functions is that it kind of mumble jumbles steps 0 and 1. Okay? So let's try one, and I'm going to show you the kind of new order that we are going to be doing. Okay? So here is the function that I would like to graph. F of x equals x minus 2 over x squared minus 4. It's all up here. Yep, always up here. Okay?
Okay, how many people need pink sheets?
Normally, you would be finding the domain and the vertical asymptotes first, correct? Okay? But now, what's going to happen is you are first going to find the domain. So what is the domain of this function?
X cannot equal plus or minus 2.
So do you want to add something to what she started with?
All
All real numbers, but,
X cannot equal plus or minus 2.
okay? So we still do that first. We find the domain first. Now we go back and we do step number 0. So step number 0 says this is really x minus 2 over x minus 2 x plus 2. The x minus 2's now can cancel each other out, leaving me with my new function of 1 over x plus 2. And now from there, now I go with the regular steps all the way through. So my vertical asymptote here now is just at x equals -2. I don't have a vertical asymptote at x equals 2 because that's where my hole is going to be. You understand that? Okay. Simplifies our graph a little bit more. Okay. Oops, too far. Right there. Okay. Then I still find my y-intercept, but I'm going to use this one now. So f of 0 is going to be 1 over 0 plus 2. That's going to be 1/2. So my y-intercept is at 0, 1/2. My horizontal asymptote is at y equals 0. My x-intercept is none. Right? Find the domain off of my original function, simplify the original function, and then use that the rest of the way through. Okay? But now I have a hole because I factored out x minus 2. So I set that equal to 0. And that gives me x equals 2. That spot where my other vertical asymptote should have been. But because I factored it out, I get rid of it. So then I find my new f of 2. So I go 1 over 2 plus 2. That gets me 1/4. So my hole is at the point 2, 1/4. I've got a vertical asymptote at x equals -2. I've got a horizontal asymptote at y equals 0. I've got a y-intercept at 0, 1/2. I don't have an x-intercept. And I've got a hole at 2, 1/4. So I literally put a big old hole on my graph.
So with that, then like, so the line, like, does it like stop and continue again? Okay.
Don't go through your hole. Okay?
Is it negative or is it positive?
Oh, I put a positive. Oh, did I put them on the wrong side?
Yeah.
Hi, caramba.
Didn't you made a mistake?
That happens. Yeah. Now I find other points. So, like -3. Should move that over just a little bit. Whoa! -3 into my function gives me 1 over -1. So that's going to be -1. -4 gives me 1 over -2. -10 gives me 1 over -8. And on this side, -1 gives me 1 over 1, which is 1. And let's do 10. 1/12. Okay. Okay. So in here now, when we go to draw in our function, on the non-hole side, or the non-hole sections, straight up normal, wonderfulness. Yes? On this side, coming in, coming in, coming in, coming in, getting close, get close, get close, stop, lift up, come to the other side, and go on. Okay. Questions, comments, concerns, clarifications? Go for it. agree with everything that I've got so far. I got my new function. Well, the domain of my original function is all real numbers, but x cannot be -6 or +1. X plus 6 factored out from both top and bottom. So that leaves me with 1 over x minus 1 as my new function. That has a vertical asymptote at x equals 1, a horizontal asymptote at y equals 0. It's got a y-intercept of 0, -1. It doesn't have an x-intercept, and because I factored out x plus 6, that means my hole is going to be at -6, -1/7. Agree with all of that as presented. Okay. So then on my graph, oh no, there it goes. On my graph, I've got a vertical asymptote at 1. Horizontal asymptote at 0. And I've got a y-intercept at 0, -1. I've got a hole at -6, 1, 2, 3, 1/7. Yes? Agree with all of that? That puts my function in on this side here. Now I just need to figure out what it is on this side. We can go with 2. If I put 2 into that function, I get 1 over 1. And 10. If I put 10 in that function, I get 1/9. Did not say we had to do end in asymptotal behavior. Yes? Questions, comments, concerns, clarifications? One more. While you do this one, I will hand out the latest of review pack or of homework packets. Homework packet number 2. Pure jealousy. answer to your question, Mandy, I got x equal or y equals 2 for the horizontal asymptote.
It was my question.
Sorry.
I was asking how to factor.
What happened to the 2?
What happened to the 2?
I don't know.
It depends on where you're talking.
The X intersects, like, where did the two just
Yeah.
disappear to?
Can I divide by both sides by 2?
Oh, yeah.
I can do that, can't I? What's 0 divided by 2? 0.
Got it.
Here. Let's see. Y-intercept. That's 4.5. 2, 4.5. 3 and 3. No hole to put on there. Okay. So, yeah, let's get back up here. And then let's go here. So we've got, already got 3. So then let's go with 4. If I put -4 in there, 16 minus 9 is 7. Times 2 is 14. 16 minus 4 is 12. So that's 7/6, which is 1 and 1/6. -10 is going to be 100 minus 9 is 91. So that's 182 all over 96. Pretty close to 2, but not quite. Then I got this middle section. -1 first. 1 minus 9 is 8. -8 times 2 is -16. 1 minus 4 is -3. So that's going to be 5 1/3. And I can do 1, and that's going to be the same thing. Yes? Yeah. Then I can come over here, and I can do +4, and that's going to be the same thing. And I can do positive 10, and that's going to be the same thing. Why are they going to be the same? Because everything's squared, right? Yep, everything's squared. So we got that. So then our function in the middle is parabolic. I also know that in the middle, it's not going to go down at all because I don't have an x-intercept in that middle section. Okay, so I know it's not going to go back down. Kind of missed there on the 3, but. Yes? Good times. Good times.